future engineers. So we have already summarized the equation of motion in scalar form or in the second order linear ordinary differential equation into this one. U of t plus c u dot of t plus k u dot t is equal to p of. Now, uh, in a second order differential equation, if there is a problem statement, and then we are given the mass of a system M, and then we have the applied dynamic load with the lateral stiffness and the damping coefficient, then eventually we'll be able to determine the displacement of the system, its response velocity. So response velocity, no, that is the first derivative of the displacement. We also have the response acceleration, that is the second derivative of the displacement of the structure. The base shear of returning moment and etc. can be subsequently derived from U of t. Now, how about sir if kato kay single degree of freedom man to, one story man to, how about if dagan story? So, kada floor or kada story, it has a differing lateral displacement or deformation. So for this one, since dili man usa ang kuan degree of freedom or ang motion, then we have three motion here, no, kada story. So the example idealized one story structure described earlier or last time is a single degree of freedom because its motion can be completely described by only one scalar function, u of t. A three-story building is a three-degree of freedom system because at least three response functions are required to completely describe the overall motion of this structure. So muna siya kay three-story man siya, a building, and then na siya ila-ila nga lateral displacement as a function of time per story or per floor. So to describe its overall motion, we need at least three response function. Wala gani siya gitawag siyang multiple degree of freedom structure. So the dynamics of MDOF, no, this is an MDOF or MDF system. Now, let's proceed with this one. So this one is again a single degree of freedom system. This is a one-story building, but this one, the building is the one-story building is not subjected to a external dynamic force, but rather the building is subjected to earthquake. So in this example, no, gikuha nato si external dynamic force, but we allow the structure to experience vibratory ground motion or earthquake in one direction. So we allow it to move in one direction. So here we have our idealized structure, and then this is the FBD of the structure. Since there is an earthquake, no, there is a ground motion. So for this one, we try to add additional, no, there is an additional displacement. Kung na displacement T of T sa building by the applied dynamic force, with this one, there is a displacement. We call that the lateral ground displacement represented by UG of T. Note that this is a vector quantity. This represents a simplified earthquake excitation or and then the ground motion here is assumed to be one-dimensional lateral motion. There is no external force applied to this SDF system. So matugingon earlier, there is no external force, but there is a lateral ground displacement symbolized by U of G of T. So to sum up na dahil sa ato pa there ang U of T ang ground displacement ani nga specific structure. Therefore, we need to get the total. So UT of T is equal to the sum of the displacement of the structure plus the lateral ground displacement UG of T. So mo din siya itong required na displacement for this structure. So same thing po no, we still have the elastic restoring force Fs of T. We also have the dynamic force Fd of T and the inertial force Fi of T. But there is no applied dynamic force or external force. So malang siya consideration 3. But not the addition na Ug of T. So kung earlier no, ingon ko nga na kung if natay lateral displacement ni building, and then if imo lang derive or differentiate with respect to time, you will have what we call the response velocity. And if imo ba lang i-differentiate for the second time around, response acceleration of the structure. Now, since namatay lateral ground displacement symbolized by UG, if imo na i-differentiate with respect to line, we will have the ground velocity. And if you differentiate for the second time around, E squared Ug of T, then we will have the ground acceleration. So we can try to denote that as Ag of T. This is a vector quantity. And we have here the velocity, the ground velocity as a function of time. And then we have the lateral displacement here, the ground displacement as a function of time again, caused by the earthquake excitation. So nanay tulo ka dynamic force nga na-apply sa ato ang structure but there is no external loading. So unsa may mahitabuan ni karon sa atong equation of motion? So let's denote the ground displacement, ground velocity, and ground acceleration. So muna akong discuss. You have the ground displacement, ground velocity, and the ground acceleration. So ang total displacement sa roof nut rock, symbolized by this one, is just the addition of the U of T, the displacement of the structure, and the ground displacement. So if you notice, no, mao ni siya ang movement sa itong structure. And then we have, so sa maning anong separated man, anong na-address si U of T. And then we have our, so that is the U of T on the side. And then we have our Ug of T on this side. So si ground gid no mismo ni move gid siya paingon diri. Pag move din niya paingon diri, si ato ang structure is nisayaw din siya towards the right or on that side. Mao na din siya si displacement sa ato ang structure. So natay displacement because of the ground movement and displacement of the building itself. So mao na din siya sa ato ang total displacement of the roof. So this is the roof of the structure. So mao na to siya nga we have this. We have the UT of T is equal to the ground, or the total displacement of the roof is equal to the ground displacement plus the uh, displacement of the structure. Since there is no applied force, that type 3 dynamic force that acts on the roof mass, you have again this elastic force and the damping force. So don't forget no with these very basic formulas. Each of these forces is a function of relative motion, not the absolute or total motion. So later on, nato na discuss. But each of these forces, so kato siya no, si elastic and si damping force are relative motion but not the total or absolute motion. However, si mass undergoes acceleration or the ground acceleration. So si mass dokulo, di undergo siya og ground acceleration, u double dot g of t, And then there's also acceleration of the structure. So doon na acceleration sa tuwang of mass. So mo na din siya mabago na din atong formula ni inertia force. So the inertia force as a function of time will become negative mass times the acceleration vertical vector acceleration of the structure minus mass times the vector ground acceleration of the structure. So mo na din siya ang absolute and total motion sa tuwang inertia force. So nga naman, nganong si mass raman ang naay absolute or total motion. So balik tani nga drawing. So if inyo ning talawon no kani siya nga drawing, if si building na siya we try to apply it with the earthquake or ground motion. So say this is its initial condition. Now, pag abot ni earthquake, so there is a ground displacement. So may tabo, si building dili pa na siya mosaya diretsyo. Mo isbog pa na siya on that side. So mabayong the ground displacement, si structure wala pa ni sayaw, but ang ato ang mass M is remove na pangon D. So that is our UG of T. Since ni-move man ang ato ang structure, mao na dito siya nga move sayaw na structure. So muna siya nga nganong si elastic restoring force Fs of T is still negative Ku of T, and the damping force Fd of T is equal to negative C U dot of T is still this one because pag apply ni ground motion, no, as from this explanation, intact pa si building na to. There is no motion right away. But as na to, so here di ba ni move na sad balik si, so pag lihok ni building, bisaya din si building, so na sa ibag o nga si mass na sad is ni move na sad siya. This is the U of T nga displacement. So to get the total inertial force, so there is an inertial force due to the ground displacement, and then there is an inertial force due to the lateral displacement of the structure. So mo na siya nga maong si kuan si inertia force is absolute. So mo na dito siya. So if we rewrite the equation, di ba, we have the elastic restoring, so the inertia force plus the damping force as a function of time plus the elastic restoring force as a function of time is equal to P of T. But since there is no applied here, so may tabo. That is just equal to a null vector. But there is a change in the equation of motion because of the addition of the ground acceleration sa tuang mass. So if we try to rewrite this one, so we will have negative m or simply m na lang, no? We have mass times the acceleration, no, u double dot of t. And then we also have another mass times the acceleration due to gravity plus the damping force or the coefficient of damping times c of t plus elastic restoring force, the lateral stiffness k times u of t is equal to a null vector. So, muna na siya mahitabo na bago si equation of motion na to. So, we have here, so in scalar form, this is the scalar form. So, ato lang ipagawas dire si katong due to the ground acceleration. So, what we did here, so on the left side, no, we have katong initial condition na to, or we have the building under earthquake excitation. And then this is its we have solved earlier. So we can also try to idealize this one as something like this. It is similar sa building nga wala siya ground acceleration but na kay applied nga effective force P or P effective as a function of time, and then it moves on both the lateral direction. So kani siya, this will become our P effective. So same lang siya nga concept ana, where P effective is equal to negative m times the ground acceleration. So this is the equation of motion of a one-story building subjected to earthquake. So kato i ibalik lang gamay.